All right, so yesterday we went over the idea of the mole, okay, this unit of measurement that kind of gives us an idea of how many particles there might be present in any given sample, okay? We talked about the mole equation, right? That's n equals little m over big M, and we talked about Avogadro's number, you know, the one that he wants all the ladies to take. All right, so what we got is we've done the first two types, the two simplest types of mole equation problems, the ones that don't involve using Avogadro's number. Okay? They just involve using the mole equation, either in a type 1, calculating the number of moles when given m, little m and big M, or in a type 2 like this one, okay, where we were given the number of moles and the molar mass, and we had to calculate mass. Now, all that's different in a type 3 question is that you will have one extra step. You will either multiply by Avogadro's number or divide by Avogadro's number. A type 3 question is really just a type 1 question with one extra step, either multiplying or dividing by Avogadro's number. And a type 4 question is really a type 2 question with an Avogadro calculation. Okay? So they're virtually the same as what we've done, they just have this extra step involving Avogadro's number. So the way that they're different is this. They will always involve either trying to calculate the number of molecules, or you'll be given the number of molecules and then asked to calculate mass. Okay? So either way, the words number of molecules will be in the question. As soon as you see anything about number of molecules, Avogadro's number is going to be involved. Okay? And all that you ever have to do with that is multiply or divide. The calculation is as simple as this. If I told you that I have 2 dozen donuts, how many donuts do I have? 12. How did you do that? 24, yeah, how did you do that? I said 2 dozen. You thought I said 1. Right? So what did you do? You went 12 times 2, and you got 24. Avogadro's number works exactly the same way. If I tell you that I have 2 moles of something, how many particles do I have? You take the 2 moles and you multiply by this number. Why? Because this is the number of particles in 1 mole. Just like a 12 is the number in 1 dozen. All right? So it works exactly the same way. Okay? If I told you I have 48 flowers, how many dozen do I have? 4. How did you do that? Divided by 4. Yeah, or divided by 12 or whatever. Yeah, when 48 divided by 12. Well, if I said I have this many particles, how many moles do I have? Then you would be going the number you have divided by this number. If you're ever confused as to whether you should multiply or divide, here's all you have to think about. If I'm trying to calculate the number of molecules, is that going to be a really big number? Right? Like even in a small sample, the number of molecules would be a gigantic number, right? So if I want to make a really big number, would I want to multiply by this really big number or divide by this really big number? Multiply. Multiplying makes numbers bigger. Okay? Whereas if I gave you a really big number and you knew you had to find like the number of moles, that would be a much smaller number. Well, then you should divide by that big number and your number will get smaller. Okay? Just think about it in kind of simple arithmetic terms and it'll kind of be obvious which one you should do. All right. Write down this type 3 example. Okay? What we're going to do today is go through a 3 and a 4 and then I'm going to put 4 more up there. Okay, and we'll go through those. So by the end of the day today, you should have probably 3 examples of each type, okay, before the end of the day. So in a type 3 question, you're going to be asked to calculate the number of molecules in a given mass of a sample. Okay? And as we said just a minute ago, when you're calculating number of molecules, that is going to be a really big number. Okay? So in a type 3 question, you'll be given mass, which you are here. Okay? You're told the mass is 600 grams. Okay? If I see the word molecules in there, then I know I'm also going to be using Avogadro's number at some point. The other piece of information this question gives me is the material that I'm dealing with, which helps me calculate big M. This stuff is silver nitrate. Okay, silver's a +1, nitrate's a -1, so that compound is okay the way I have it written right now. All right, so I've got to calculate my molar mass. That's what we learned to do yesterday. So for silver, that's 107.87 plus how many nitrogens? Just one? Yeah, so 14.01. And how many oxygens? 3. Okay, so we'll have 16 times 3. All right, so that's going to give us a molar mass. Okay, so 107.87 plus 14.01 plus 16 times 3, 169.88 grams per mole. Okay, I have little m, I have big M. The question wants me to find out the number of molecules. Okay, incidentally, this is number of molecules, not hashtag molecules. Okay, and back in the day this meant number. I don't mean something else now, but I'm too old to change. Okay, so we're looking for the number of molecules. What can I calculate right now if I have little m and big M? N, yeah, I can calculate the number of moles. That's what the mole equation is designed to get me. All right, so even if I'm lost at this point and I don't really know what to do, at least I can calculate that. Okay, so I'm just going to put in that I have 600 grams, and I'm dividing that by 169.88 grams per mole. Okay, do I have more than a mole here? Quite a bit more than a mole, right? So I should get, a decently sized number. All right, so 600 divided by the 169.88. Okay, so I have 3.53 moles. Now, rules here. Don't round until you're finished. Okay, only your final answer should ever get rounded. Carry all your decimals through. You're going to see why that's going to be important here with this number in just a minute. I'm just going to write on the board 3.53, okay, but I'm keeping all the numbers in the calculator. So I have 3.53 moles. Question wants to know how many molecules are there in 3.53 moles. So what does his number represent again? The number of
particles
in a mole. Right. This is the number of particles in 1 mole. I have 3.53 moles. What should I logically do with those two numbers then? Multiply them, right? I'm looking for a really big number here. So I'm going to take the number of moles that I have and multiply by the number in 1 mole. In the same way you did when I asked you if I have 3 dozen, how many do I have? You went 3 times the number in a dozen. 3 times 12. We're doing the same thing here. Okay? So to get the number of molecules, okay, I take the number of moles, N, and I multiply by Ab's number. In this question, that looks like this. 3.53 moles times 6.02 times 10 to the 23 particles per mole. Okay, that's essentially what the units are. Okay, now the question is, how in the heck do I put that into my calculator? Right? If you have any Texas Instruments product, okay, even if it's not the graphing calculator, it's still set up the same way. Okay, you would be looking for your EE button. Okay, it's usually the second function of something. Okay, on a Texas Instruments calculator. On other brands, it might be an EXP button. Okay, so if you don't see an EE button, you might have an EXP button. Right? If you can't find either one of those, let me know and I'll come and help you. Okay? In any calculator, Avogadro's number needs to be in brackets. Okay? If you don't enclose it in brackets, it tries to make the next number part of the exponent and it messes things up. All right, so I'm going to take my 3.53, that's n, and I'm going to multiply it by Avogadro's number. That looks like this, bracket, 6.02. And then, if you have a Texas Instruments calculator, second function, and the EE button. It's actually the comma, okay? And oddly enough, when you press EE, you get one E. I don't know why, that's just the way it is, okay? Then the next number you put in is the exponent, 23. So the little e actually means times 10, and then the next number you put in is the exponent. So in this case, 23, and you close the bracket. Okay, everybody with me there? All right, now I just hit enter. All right, that's a big number, agreed? And 23 and close bracket. All right, so my final answer then is that, and we can round this to 2 decimal places, 2.13 times 10 to the 24. Okay, so my number of molecules will be 2.13 times 10 to the power of 24 molecules. Okay, now that makes sense. That number is bigger than Avogadro's number. 3.53 times bigger than Avogadro's number. Okay. Is that making sense? Okay, so really, that was a type 1 question. I had to calculate the number of moles, and then I just multiplied that number by Avogadro's number. Okay, it's a 4-mark question. A type 1 question is a 3-mark question. Okay, so you would get 1 mark for your givens, you'd get 1 mark for calculating the number of moles, and you'd get 1 mark for your calculation of number of molecules, and 1 mark for your final answer. 4 marks. Okay. Did you put times 10 here? Just hit don't put in the 10. E means times 10. If you put in times 10 and then go E, that's 2 10s. So that's why it's giving me 25 and not 24. Okay, any other questions? Everybody got their calculator figured out? Then, copy down this type 4 question. Give you a second and we'll go through it. So in a type 4 question, it's basically backwards of what we just did. The thing we're given was the end product of what we did in the last one. Okay? We're told the number of molecules. In this question, it's 1.54 times 10 to the 25. Okay? Do I have more than a mole here? A lot more than a mole, right? Like it's somewhere between 10 and 100 times more. Okay? Because it's 2 exponents bigger than Avogadro's number, right? Avogadro's number is 10 to the 23. This is 10 to the 25. So it is anywhere between 10 and 100 times bigger. Okay, so I've got a lot. The other thing it tells me is it wants to know the mass. Okay, so I'm going to have to do that. And they tell me the material. Diphosphorus tetraiodide. Should I reduce that? No, because it's molecular, right? If you're given prefixes, those are the numbers. We only reduce ionic compounds. All right, so if we're doing the molar mass for this, we've got 2 potassium, so 30.97 times 2 plus 4 iodines, so 126.9 times 4. 30.97 times 2 times 4. Okay, 569.54. Grams per mole. All right, that's all I'm given to start with. If I want to calculate little m, what else do I need that I don't have? N. Yeah, I don't have the number of moles. What I do have is the number of molecules and the number of molecules in 1 mole. Can I get the number of moles? What should I do with those two numbers? Divide them, right? Because the number of moles is going to be a much smaller number by comparison. By dividing those two numbers, I would get the number of moles. Okay, so N is going to equal the number of molecules divided by Av's number, because that's the number in 1 mole. So we take our 1.54 times 10 to the 25, and we divide it by 6.02 times 10 to the 23. Both of those numbers need to be enclosed in their own brackets in your calculator. Right? So it's going to look something like this. Okay, so we'll have in brackets 1.54 second E25, close the brackets, divided by, open bracket, 6.02 second E23, close that bracket. Okay, well, as predicted, it was somewhere between 10 and 100 times bigger, right? 25.58 moles. Right? I'm going to keep all those decimals, right? Just like I did in the last one. All right, so 25.58. I'm just going to write 25.58, but I'm keeping those in my calculator. Okay, now that I have N and big M, can I calculate mass? Okay, but do I have to manipulate the mole equation? I do. That's why this is a 5-mark question, right? You actually have to do some algebra in this one. So N equals little m over big M. To get little m, I would multiply both sides by big M. Okay, now I'm solving for little m. So that will be the 569.54 grams per mole multiplied by 25.58 moles. When I multiply those, the moles are going to cancel, and I'll be left with grams, which is what I should get. That's the units for mass. Okay. It's going to be a big number. Yeah, I got 25 moles of this stuff. It's probably going to be pretty heavy. All right, so I'm taking my 25.58. And I am multiplying that by the molar mass, 569.54. Okay, I do have a lot of this stuff. That's 14.5 kilograms, roughly 30 pounds of this stuff. Okay, that's not an unreasonable amount for 25 moles. Okay, it's quite a bit of stuff. Okay, so our final answer here would be 14,569.63. grams. Okay, so 5-mark question here. Okay, you would get a mark for your givens, as you always do. You would get a mark for calculating the number of moles. You would get a mark for your algebra. You would get another mark here for the plugging of numbers, and a 5th mark for your final answer. Okay, questions on that? Okay, you now have one example of each of the 4 types of mole equation problems. Okay. All right. Okay, so there they are. Give those a try. Yes. Go get it. Anybody else need to go get their calculator? Oh, at home. Okay. Okay. So number 1 is a type 1 question. In this one, they're asking for the number of moles, N. So I'm not going to have to do any algebra because that's what the mole equation is set up initially to do anyway. They do tell me that it's carbon dioxide, so I can calculate the molar mass, right? I'm going to have CO2, and that is going to be 1 carbon, 12.01, plus 2 oxygens, 16 times 2. That should be 44.01 grams per mole. Okay, everybody with me so far? All right, the other thing they tell me, the mass. I have 150 grams of carbon dioxide. All right, since I have little m and big M, all I have to do is put it into the formula. 150 grams divided by 44.01 grams per mole. Okay, I definitely have more than 1 mole here, right? So you'd get 1 for your givens, 1 for your math, okay, and then 1 for your answer. So 150 divided by 44.01. So we would have, to two decimal places, 3.41 moles. Okay, that would be your third and final mark for number 1. Okay. How many people have done the second one? Okay, I'll put them back up and give it a little bit more time. Okay, let's have a look at number 2 here, guys. All right, so number 2, we're being asked to calculate the mass, okay? And they tell us the number of moles, 26.5. That's a lot, okay? That's a lot of moles. Of cobalt 2 bromide. So they do give me the ability to calculate the molar mass. Cobalt with the 2+ charge, with bromine, which is a -1, drop and swap. Guys, a pretty common mistake that I'll see is in exactly a compound like that, if I write it in words, people won't drop and swap it. And if they don't, then they don't get the molar mass right. And you can't get anything right from there, right? So always check when I give you the name that you've either done the prefixes correctly if it's molecular, or dropped and swapped correctly if it's ionic. Okay, so for cobalt, 58.93. Okay, 58.93. There's only 1 cobalt, but there's 2 bromines, so 79.9 times 2. All right, so 58.93 plus 79.9 times 2. Okay, 218.73. grams per mole. Okay, this is a type 2 question then. Okay, because I'm being asked to calculate mass. I don't have to use Avogadro's number here, right? So this is just a type 2 problem. N equals little m over big M. I want to get little m by itself. What do I have to do with big M? Multiply both sides by it. Okay, so if I multiply this side by m divided by m is 1, which cancels it. Big M comes over here. All right, so little m for this question then is going to be the 218.73 grams per mole times 26.5 moles. So probably going to get a pretty big number here again. Okay, so we're getting 5,796.35 grams. So that's 5.7 kilograms or 5.8 kilograms. 12, 13 pounds worth of stuff. Okay, so 5,796. And my units are grams. Okay, making sense? All right, now you know on the type 3 and 4, you are going to have to use Avogadro's number. Okay, either multiplying or dividing by it, that's all you ever do with it. All right, give you a few more minutes to get ahead. Okay, number 3 wants to know the number of molecules. All right, so we got number of molecules is the question mark. Since I saw the words number of molecules, I know that Avogadro's number is going to be part of this at some point. Okay. I also know that the material is sodium sulfide. So Na plus 1, sulfide minus 2. So I got Na2S as my formula. So that'll be 22.99 times 2, my 2 sodiums, plus 32.07 for my sulfur. Okay. 22.99 times 2 plus 32.07. Okay, 78.05. grams per mole. And the other thing I'm told is that the mass is 29 grams. Okay, with little m and big M, can I get the number of moles? Okay, then that's what I should do first. I should calculate n, the number of moles. Little m over big M, so 29 grams divided by 78.05 grams per mole. Do I have more or less than 1 mole here? Less, like, yeah, about half, yeah. Okay, so when I divide this, is it okay if I get a decimal? Absolutely it is. So n equals, right, 29 divided by the 78.05, right, 0.37 moles. I'm going to keep all those decimals in my calculator. I'm just going to write this far on the board. Okay, so that's how many moles I have. Question wants to know how many molecules I have. Since this is the number of molecules in 1 mole, what should I do with this number and the 0.37? Multiply, exactly. Okay, so number of molecules, okay, equals n times Ab's number. Okay, and then we just put those two together. So 0.37 times 6.02 times 10 to the 23. Okay, so take that number and multiply it by, in brackets, 6.02 second E23. All right, so I get obviously less than Avogadro's number, which is appropriate, 2.24 times 10 to the 23. What are my units? Molecules, yeah. This is the one people forget to put units on all the time. Okay, when they calculate mass or moles, they always remember, but when they calculate molecules, they forget to put molecules at the end. Okay, that's the units, that's what you calculate. Okay, questions on number 3? All right, I'll put number 4 back up there. Okay, give that one. So with number 4, they're asking what's the mass. So I'm looking for little m here. And they tell me in this one the number of molecules. Okay, and it is 7.2 times 10 to the 23. So just ever so slightly more than 1 mole. Okay. And then the other thing they tell me is that it is diphosphorus pentaoxide. So I can calculate the molar mass. So that'll be 30.97 times 2 plus 16 times 5. Okay, so we're looking at 141.94 grams per mole. Okay. If I'm going to calculate little m, then I need to have n. Would you agree? Okay. How can I get n with the information that I have? Okay.
Molecules divided by Avogadro's number.
Right. Molecules divided by Avogadro's number, which remember represents the number of molecules in 1 mole. Okay. So if I divide those two numbers, that will get me the number of molecules, right? Because I'm going number of molecules divided by 6.02 times 10 to the 23, essentially molecules, okay, per mole, right? So the molecules would cancel and I'd be left with moles. Okay, so when I do that, that's going to be 7.2 times 10 to the 23 divided by 6.02 times 10 to the 23. Now, if you're like really on the ball with your math, do you need to put the 10 to the 23 in here? If they have the same exponent, you could actually just divide the bases, but I don't want to confuse anybody, so I'm just going to put the whole thing in. 7.2 E23 divided by 6.02 E23. Okay. Okay, so I have 1.196 moles. Okay, now that I have N and big M, I can calculate little m. I got to do a little manipulating, but that's it. Little m over big M, I just need to get little m by itself, multiply both sides by big M. All right, so little m is going to be 141.94 times 1.196. Okay, so that's grams per mole, that's moles, I'm going to be left with grams. Okay, so at the end I've got 169.76 grams. That's my final answer. Okay, was making some sense? All right, you now have 3 examples of every type, right? Or is that only 2? That's only 2, okay, sorry. I gotta put the other list of 4 up. But I'm gonna give you about a 3 or 4 minute break here. Get up, walk around. Okay, little body break. So, 4 more. Okay, so at the end of the day today, as I promised, you'll have 3 examples. I miscounted already, but there's 3 examples of each type. Tomorrow, okay, we'll go through another 4 at the start, and then we're going to work on that worksheet that I handed out to you. We'll probably get to that worksheet today. Okay, I'm going kind of fast. I'm trying to get through so you guys know all of this stuff. Okay, before that stuff that goes on there. Okay, so for number 1 here, we got a type 1 question. It's just asking us how many moles are there. Okay, so we're looking for N. They tell us the material, it's calcium carbonate. Okay, so we have 40.08 for the calcium, plus 12.01 for the 1 carbon, plus 16 times 3 for the 3 oxygens, okay, to get our total molar mass there. So 40.08 plus 12.01 plus 16 times 3, right? It's going to give us 100.09 grams per mole. Okay, and then looking for mass. Or sorry, we have mass, not looking for mass. We have the mass. It's 125 grams. Okay, we have little m and big M. All we have to do is plug into the mole equation. No algebra required. 125 divided by 100.09 should come out to 1.25 moles on that one. I think it's 124.9 something. Okay. Or 1.249 something. Right? Yeah. Questions on that one? We good to go over number 2 as well? Okay, in number 2, we're looking for mass. So in this one, we're looking for little m. That's a type 2 question because we weren't given any number of molecules here. They do tell us the number of moles, 2.7, and they tell us that it is lithium phosphide. Okay, so Li3P, so that will be 6.94 times 3 for the lithium, plus 30.97 for the phosphorus. Whoop. Times 3 plus 30.97. That's better. Okay, 51.79 grams per mole. All right. I have to do a little bit of algebra here because the mole equation is set up for N, not little m. So multiply both sides by big M, and I'm set. Just have to plug in my numbers. 51.79 times 2.7. Okay, so 139.83. 2 decimal places is always good enough on these. And that, what are the units for that going to be? Grams. Okay, questions on number 2? All right, I'll put 3 and 4 back up there and give you a couple more minutes. All right, for number 3, we're looking for the number of molecules. Okay, that means we're also going to have to use Avogadro's number. Okay, they tell us the material. It's iron 3 oxide, Fe2O3. So that'll be 55.85 times 2 for the 2 irons, plus 16 times 3 for the 3 oxygens. Okay, so 55.85 times 2 plus 16 times 3. All right, we're looking at 159.7 grams per mole as our molar mass. And they tell us there's 230 grams of it. All right, remember, a type 3 question is really just a type 1 question with an Avogadro number calculation after that. So I'm really just looking for the number of moles, because right now, that's all I can calculate with what I'm given. So I just punch in my numbers here, 230 grams divided by 159.7 grams per mole, okay? So a little more, maybe 1.5 moles, something like that. It should be a number I would get here. Okay, so 230 divided by the 159.7, 1.44. Okay, I have 1.44 moles. Question wants the number of molecules. What do I do with that number and Avogadro's number? Multiply. I want a bigger number here. The number of molecules is going to be big. Okay, so 1.44 with all the decimals from my calculator times Avogadro's number, 6.02 times 10 to the 23. Okay, so I'm going to take that number with all the decimals, multiply by, in brackets, 6.02 second E23, close the brackets. All right, I'm looking at 8.67 times 10 to the 23 molecules. Okay, that's my final answer. Questions there? How many people have done 4? Okay, give you a couple more minutes on 4 and then we'll do that. Okay, let's have a look at this one. This one sometimes throws people because of the number they get partway through it. Okay, it's a type 4 question because it's asking us to calculate the mass when given the number of molecules. Okay, here's what we have to realize. 5.42 times 10 to the 21 is a lot smaller than Avogadro's number, which is times 10 to the 23. It is 2 factors of 10 smaller. That means it's somewhere between 100 and 1,000 times less than Avogadro's number, than 1 mole. All right, so when you got 0.009 on your calculator, that was okay. You were supposed to get a number that small, but it throws you off because it feels like it's wrong. Okay, but it's absolutely not wrong. Okay, so we've got the number of molecules and we're told the material is nickel 2 nitrate. All right, so if I'm calculating the molar mass of this stuff, first I have nickel, which is 58.69. There's only one of those, okay? Plus, how many nitrogens? 2. So 14.01 times 2, and how many oxygens? 6. Okay, so 58.69 plus 28.02 plus 16 times 6. All right, so we're looking at 182.71 grams per mole. Okay, if I'm going to get little m, if I'm going to get mass, then I need the number of moles, which I get by dividing the number of molecules by Avogadro's number. Okay, so that's going to be 5.42 times 10 to the 21 divided by 6.02 times 10 to the 23. Okay, so when I punch that in, both of those numbers need to be bracketed. 5.42 E21, okay, 6.02, E23, and I get this really small number, 9 1,000ths of a mole. And that's okay, it's a really small amount, okay? So I'm gonna take that number, and I'm just gonna write 0.009, but I'll keep all the decimals in my calculator, moles. Now that I have n and big M, now I can use the mole equation. N equals little m over big M, and I multiply both sides by big M. Now I'm solving for mass. So that's 0.009 moles times 182.71 grams per mole. Okay, so when I do that multiplication, the moles are going to cancel, and I'm going to be left with grams. So that number times 182.71. Okay, so I end up with 1.64 grams.
I'm just a little confused because my calculator gave me 9 to the power of times 10 to the power of -3, and then
Right, which is the same number.
It's the same?
Yeah, that's the same number.
Okay.
Okay, so scientific notation. Let's just talk about that once we're done this one here, because that's a good question. Okay, so my final answer is 1.64 grams. Okay, you may or may not have learned about scientific notation yet. Scientific notation is a way of representing either really, really large numbers or really, really small numbers in a more reasonable format. Okay, so 0.009 in scientific notation is 9.0 times 10 to the -3. If the exponent is negative, it means the number is really small. It means I've moved the decimal 1, 2, 3 places to the right. And I'm representing that really small number as a factor of 10. But it's 10 to the -3, that's 1,000, right? If I had this number, okay, 12,345, and I wanted to write that in scientific notation, I would write it as 1.2345 times 10 to the 4, because the decimal's here, and I went 1, 2, 3, 4 spaces to the left. Okay? In scientific notation, your base number is always between 1 and 9.9. Okay, it's never bigger than 10, it's never less than 1. And all you do is put times 10 to the power of, and that power is however many spots you move the decimal to get it to there. Okay, this number, okay, was 12,345. I made it 1.2345 by moving the decimal 4 spots. That's 4 factors of 10, because our numbering system is a base of 10. Every decimal spot is 10 times bigger or smaller than the other one. You're going to use scientific notation a lot. We'll talk about it more after everything is done. Okay, tomorrow we're going to do more mole stuff. Good work today, guys.